Alright, so all queens were placed on the board, and we made sure that no two queens share a row or a column. So we are ready to verify that no queen is attacking diagonally on our chessboard. And if no queen does, then we have a winning placement of the queens, and we can end the loop and display the final board on the screen. So I'm just going to add another method, and I'll call it isWinner. And the method will return true if the queens are in correct positions, or false if not. First, we can display the board after each round. This is not needed. We could simply run the program and display only the last board with all the queens in correct positions, but by displaying each unsuccessful round on the screen, we will be able to visually confirm that our algorithm is working. I will also separate each display by a blank line, just so we have a visual separation between the boards. So I'm calling the display board method, and then I'm adding a blank line. And now we can verify the diagonal positions. And this is the trickiest part of the whole algorithm, so let's go to PowerPoint and discuss our strategy first. So we need to verify diagonal positions in 4 quarters of the chessboard. First, we can start from the top left corner and go down. Now you can see there are 7 diagonal possibilities. Well, there's actually 8, but the last square in the 0th row and 7th column is just 1 square, so there cannot be any other queen diagonally from there going this direction. So first, we verify that there's no more than 1 queen in any of the 7 diagonal positions. Then we can verify the other 7 positions, this time going from top right corner down. So what we can do is go like this. Then we can continue going from the bottom right corner up. Like that. And finally, from the left corner up. Like that. So basically, we will divide the board into 4 quarters, each with 7 diagonal positions. And each of the quarters will start from 1 corner of the board. The ones that start on the top will go down, and the ones from the bottom will of course go up. So we will have 4 separate loops, each checking one of the quarters. Alright, so let's analyze the first one. Now as you can see, we start from the position 0, 0, which is the top left corner. In fact, we start each verification of this quarter from the row 0, and we are moving by 1 position to the right for the starting column. So we start from 0, 0, then 0, 1, then 0, 2, and so forth. So notice the pattern in the moves. As you can see, for each of the moves within each iteration, we are symmetrically increasing the rows and columns by 1. So we start from 0, 0, then we go down 1 to 1, 1 indexes, then 2, 2, and so forth. So let's translate that into code. Unlike usual nested loops, we will have the outer loop looping through the columns and not the rows. Why? Well, because the outer loop iterates by 1, so if we used it for the rows, the first iteration would start from row 0, but the next one would be from row 1, then the next one from row 2, etc. And like I said, we need to start each iteration in row 0. So we switch the loops for columns and rows. So that's our first line over here. So we start from columns, and the inner loop will be rows. Okay, so now our inner loop always starts from 0, as you can see. And it moves down by 1 until the last row is reached, which is row 7. But notice, we only loop through the columns from the indexes 0 and 6, which is our column is less than 7. And that's because the last iteration, as I said, would be through the 1 square only. So we don't have to perform that one. Alright, and as we loop through the inner loop, you can notice that we loop through 7 minus c over here. So that is our limit for the inner loop's iterations. And remember, our inner loop loops through the rows. So why is that, you may think? And here's what's happening. The first longest diagonal from 0, 0 to 7, 7 goes over all rows from 0 to 7. But the next one only goes from 0 to 6. You can see row 0 and it ends in row 6. The next one starts from 0 and ends in row 5. So we need to loop one less time for each iteration. And if you look at the index C, how it changes, you can see that it increases by 1 with each iteration of the outer loop. So we start at 0, and 7 minus 0 is of course 7. So our first loop will be looping through index 0 and 7 included. But then we go to our outer loop, our column number increases to 1, so now 7 minus 1 is 6, so we loop in through row indexes 0 and 6. The next one column is 2, so we will be looping through 0 to 7 minus 2, which is 5. And at the end, the column will be 6, and we loop through just the 0 index to 1, because 7 minus 6 is 1. So that's our last iteration. Alright, so now let's analyze the next line in the code. So this is simply the position of each square as we loop through each diagonal. But why do we add a row to a column for our second index? The first is just a simple row. We start from 0, then 1, 2, 3, and so forth. But column, you can see, has a column plus row. Well, the row increases by 1 in the inner loop, so that 1 is moving sequentially from 0 to the end of the diagonal. So the first diagonal starts from 0, 0, then 1, 1, 2, 2, and so forth. But then we start from column 1, and still the row 0, so it's 0 and 1 index. But then we have index 1, 2, then 2, 3, and so forth. So if we didn't add the row, which increases by 1, then we would not move diagonally, but simply follow the column straight down. So we are adding plus 1 to our column, and we are using the value of the row index for that, because that one increases by 1 in each iteration. So you can see that our row starts from 0, our column starts from 0, so we start from 0, 0, then it's going to be 0, 1, 0, 2, and so forth. Alright, so let's put it into an actual code. So let's go to our isWinner method, and first I'm going to create a variable that counts queens in each diagonal. And every time we find a queen in a diagonal that we are looping through currently, then we will increase the counter. So I'm just calling it attacking queen counter. Alright, now let's create the nested loop. So this is exactly the same loop as you saw on the slide. So now, how are we going to find the queen? Well, remember, every queen is represented by a queen character, and every empty square on the board is represented by a board character. So if we do not encounter an empty square, we know that the square has a queen on it. So we go through each cell in the diagonal and check if the square does not have a board character. And the board indexes are R, which is row, and C, column, plus R, and it's the same as you saw and as I explained on the slide. So these are the diagonal squares, and if the square does not contain board character, meaning it is not empty, then we increase the attacking queen counter by 1, because we just found a queen. And if we find one more queen, then we can simply exit, because we know that this round did not position all the queens as needed, meaning at least 2 queens are attacking each other. But this logic is going to be used for each of the 4 loops, so I'll put it in a separate method. Basically, the method will count the queens and return false if more than 1 queen is found. So I'm just calling the method countQueens, and I pass the current number of attacking queens as argument. Remember, we allow for 1 queen to be in a diagonal, so we can simply check if the counter is greater than 1. So if the attacking queen counter is greater than 1, then we know the queens are not in the correct places. And we can of course return false. But before we do, we want to reset everything for the next attempt. So we reset the queen counter back to 0, and we clear the used row array. And we prepare the board for the next round by initializing each square with a board character. And of course we return false. Now if the attacking queen counter is not greater than 1, then we can return true, meaning that no more than one queen was found on the diagonal so far. So that's our count queens method. So now we can go back to our for loop in the isWinner method, and after we found the queen and increase the counter, we can now call the count queen method and pass the counter to it as an argument. And if the count queens return false, then isWinner can return false as well. Remember, before we return false, the count queens method already prepared everything for the next attempt, so once we return false here, we can go and try to place the queens on the board again. So we'll do an if statement, and we will call the count queens, and like I said, if count queens return false, we have to of course pass the attacking queens counter to it. Then we can return false from here as well. And if we pass through a diagonal, meaning we pass through the inner loop without returning false, we can go now to the outer loop and perform loop through the next diagonal. So before we do that, we need to reset the counter because there still could be one queen in it from the last diagonal we checked. Remember, one queen per diagonal is okay. We only return false if there are more than one queens in any diagonal. So after the inner loop, we will set the attacking counter to 0. Alright, so that's the first quarter of the board, and in the next video we will continue to code the logic for the other 3 quarters of the chessboard. So thank you for watching, and I'll see you in the next video.